So hello guys, welcome to our next video in the playlist Google Earth Engine for the beginners. So in today's video, we will look it into how we can filter an image collection. So particularly the Sentinel-2 dataset and harmonized dataset, satellite dataset, which we can filter to our boundary and date. We can also filter the metadata to clear the cloud cover, and we'll see how much images will be available for our filter. So let's start by importing our Sentinel dataset. So this is a usual step. We are searching in the dataset catalog as Sentinel. So if you can just search Sentinel, we have the datasets which are relating to Sentinel. So the first one will have the Sentinel-1 SAR ground range detected. It's a C-band SAR data. So in today's video, we will just filter the optical for the optical remote sensing data, the level 1C, and we'll open it. So if you here you can see the dataset is available from 2015 June 27 to till the present, and if you see the resolution of the band, it is 10 meters, and if you see the band numbers, we have up to 12 number of bands, short wave, near infrared 1 and 2, and we have quality pixels also. So which is not required as of now. We'll just import this Sentinel-2 dataset, rename it as S2. So after this, we'll create an variable called as image. So let's see how we can filter this dataset. So we'll select our Sentinel-2 dataset. So this particular dataset, what we have is the millions of images which is collected all around the world from the date of its launch. So we need to filter this dataset to our region of interest, to the date of our region, to the date of our interest, and we should also filter the cloud cover. So this is the basic step for filtering any satellite image. So let's define our region of interest. So we can search any region in the world in the same search bar. So I'm searching it for, let's say, Bangalore. Okay, so now my map is in Bangalore. So I'm using the drawing tools in order to mark my region of interest. So let's take a single point. I'm marking at the center of Bangalore. So let's rename it as region of interest. So remember, it should be a geometry. It should not. It can be a feature collection, but if you have any kind of raster data set, you can just use the point geometry function in order to convert an raster data into its geometrical shapes. So now I have my region of interest, that is Bangalore, located in the Karnataka state of India, and I have our Sentinel-2 dataset which I need to filter now. So for this particular dataset, I'm applying the function filter bounce. So there is one more trick that you need to know. If you don't know the full function, you can just click on writing how much you know, and you can click on control plus space button, so it will be automatically completed. So here you see this filter bounce geometry. This shortcut filter a collection by the intersection with this geometry. So this is what we need exactly. So you can specify the input needed for it, which is our ROI, that is the point geometry. So after filtering it to our region of interest, let's just see how much of images is available for as of now. So we are using the function print in order to know how much image collections are available for our region of interest. So I have clicked on the run. So the image collection is computing. I think it's much larger. Yeah, we have 260 elements. 260 stack of images are there at our region of interest. So let's filter it to date. Let's filter to the latest data set, like 2024 January to, let's say, 2024. I will take this December month only. What's the date of yesterday? Okay, we'll take today only. It will take it as an input, but it will be available only for those images which it has captured. So now if I click on the run, let's see how much of the images are available for this data set. So remember, I have used the function dot filter date. Okay, so we have 69 elements for the 2024 year for my region of interest. If you can just expand it, here you see the features. So if you just go to the properties, here you see the cloud pixel percentages are more. The 76% cloud pixel percentage is there in our images, so we need to filter this cloud cover also. So if you're working with the cloud cover, there is no use of it, your analysis will be less accurate. So we can use the two functions. One is our filter metadata in order to filter the cloudy pixel percentage. So you can just go to our dataset and come to the image properties. The first property you will see, it is the cloudy pixel percentage, which is the taken from the original metadata. So just copy it and paste it in here. So we have the property which we need to filter from the metadata, and I also need to give the argument to be less than, and let's say the cloudy pixel percentage would be less than 0.1%. So let's click on the run again. See, now we have only 9 elements which have less than 1% of cloud cover. Yeah, if you can just go to the properties, here you can see 0.006. So we can also filter this cloudy pixel percentage with the help of one more filter. Like you can just use dot filter, open it, and open the bracket and use the filter ee.filter.ld, which stands for less than, and I should have my property, it should be less than, let's say 0.1. You can also use this filter also. See, the results are same. We have again the 9 elements, so we have the same results as 9 elements. So that's it for today, guys. We know how to filter an image collection for the boundary, for the date, and also for the cloud cover. So this is enough for any optical data. So in the next video we'll learn how to do an image composite, how we can mosaic it, and how we can visualize the layer. So remember to save this layer, and thank you for watching.